Hello, and welcome to another edition of 10 Buck Test Bench from the Radio Mechanic. I am the Radio Mechanic. And I'm sorry for not producing any videos for the last few weeks, or a couple of weeks. I've been on a business trip and just returned home and trying to catch up on everything. I haven't even been answering comments, and I apologize, but I've been awful busy. Haven't been home and been putting in long hours for the job. At any rate, we're back home, and we have some treasures that arrived in the mail while I was gone. This is 2 of them. The third one we'll do another video on at a future date. What we have here are 2 different generations, or 2 different versions of the Precision Series E-400 sweep generators. These are the companions for the E-200 signal generator that we did in a previous video. This one, of course, looks very much like the signal generator, but this is a fairly early version. Later versions had this knob. They had a vernier drive in the center of the dial like the signal generator does. This one has a rim drive. Latter versions had this type of a drive that you see on this one, and this one's in phenomenally good condition. This one looks practically new. Other than a few chips in the paint, it's clean. The front panel is unscratched. It's in excellent condition. This one is looking a little bit the worse for wear. However, this is a true $10 score, and we fully expect to get this up and running. The one thing that worries me is a lot of the front screws are missing, which means somebody may have been inside of this. We will find out. This one, however, appears to have all the original hardware fully intact and probably has never been messed with inside. With this unit, I got this manual, and it was advertised as coming with an original manual. Well, this is a manual for the E-400 sweep signal generator. However, it is not the manual that goes with that unit. Much closer to what's in that unit is my other manual. I did pick up one from Tucker Electronics. This one more closely, I think, will resemble the interior of that unit. This one is very close to what's in this unit, and in fact, this one shows the vernier drive on the edge of the dial. It shows this black case design. There is, in fact, it has the fuse right here, as this unit does. However, the manual mentions the switch, which this one has here, for the blanking, for the retrace on the oscilloscope. This one does not have that switch. I have not opened this up to see if that circuit is in there. Perhaps they added the switch to remove the blanking function, or maybe this doesn't have it at all. I haven't looked inside yet. We haven't looked at it. The blanking circuit is extremely simple. It's a switch, a resistor, and a rectifier. They were using a selenium rectifier in the schematic, but a solid state diode should work just fine for blanking the retrace. This is missing a chicken head knob and missing these 3 knobs here. However, I have a fairly well supplied junk box. We have an exact duplicate of that chicken head knob, so we can replace that guy. These knobs are very similar in form to the originals, although the dial indicator on them is slightly different. The other ones, I believe, had an arrowhead. These have a simple line, but they will fill the 3 empty slots, and certainly they are correct for the period. And the diameter of the knob is correct. It correctly matches the arc of the numbering here, so it lines up almost perfectly. So once those are on, nobody will ever know that those are not the original knobs that came with the unit. Of course, for my $10, I got plenty of extra dirt and junk. This is going to take some serious cleaning. We're going to have to get inside and recap it. This other unit, of course, will be recapped, but it will take very, very little cleaning to bring this one back. The one thing I do have to find is the correct connector for these jacks on the front. These can be easily converted to BNC. These are those microphone style jacks. This, however, uses a much larger diameter hole, and I have never actually seen the plug that goes into this style. It obviously has a pin in the center of it, and it looks like it fits into the recess, plus the threaded outside ring, which is just about identical to the threads on these. I don't know what I'm going to do with those yet, because that's the main RF output for these. The main thing is it's intact. It has its lucite or plastic dial indicator. I've seen these, somebody trying to sell one of these on eBay. He's asking $50 and $60 to ship it, and it doesn't even have this piece or the vernier scale that's incorporated into that. Without that, the thing's virtually worthless. Where these people come up with these numbers to ask for this old test equipment is beyond me. Now, I paid about 3 times what I paid for this one, and it included a manual. Again, it's not the exactly correct manual, but at least the operation would be the same. It's clean. This one I bought simply as a collector. I spent more money than I'm telling you to spend on test equipment. We try to keep everything within $10, but now I've hit the point with this line of equipment where I am collecting, quote unquote. I'm not buying these because I need one. I'm buying these because I like to try to collect them. Now, you'll notice this is a fairly big unit compared to this one. The height is much larger. However, the 2 front panels are identical. Different paint scheme, but the size is identical. The crystal setup's the same. All the switches are the same, except this one has the blanking switch on the front, and the fuse, which is here, is moved to the rear. Surprisingly, this unit is heavier than this unit. This unit weighs in at 19.3 pounds. This one weighs in at 17.6 pounds. And I suspect the difference is this appears to be an aluminum case versus steel. And that's probably most of the weight difference. I suspect the internals are very, very similar. There are, however, some differences. Where this one has a 6J6, a 6C4, another 6C4, another 6C4. This one has a 12AU7 incorporating 2 tubes in one. So the oscillator are combined into a single tube on this one. What other differences stand right out immediately? Other than the schematic's been redrawn. They both show the blanking circuit. This one says selenium rectifier, and it shows the switch. A switch, a resistor, and the rectifier diode, which is a selenium in this one. This one has the switch, the resistor, and the selenium rectifier. So the circuit's the same, it's just drawn differently. I have not looked inside of either one of these yet, but I suspect this unit, being in a new style case, the one that's on the right, I suspect probably has the 12AU7 oscillator and crystal amplifier, or the crystal oscillator, where this one probably has, on the left hand side, is probably all octal tubes. We're not going to get inside both of them today. What I am going to do is I'm going to take this one apart, and we'll take a quick look inside, and you can see it needs a very good cleaning. It's quite filthy. We'll touch up the paint on this, clean up the lucite, we'll clean the dial up, we'll get that physically looking decent, and we'll recap this one first because this matches the signal generator. This has the same style, and what I'm going to have to do now is find the signal generator in this style case, the later style case, so that I can have a matched pair of these. This unit is, I can't even hope to find the signal generator in this kind of condition. This thing is just spectacularly clean. Again, other than the chips in the paint, which are easily fixed, the front panel is unscratched. Somebody has put a serial number down here with an engraving tool, but that's barely visible. The lucite piece is clean, scratch-free. The dial is nice and shiny, like it's new and it's clean. I can't get over the condition of that unit. There's no rust on the screws. This unit was taken care of. Obviously, somebody cared for that piece of equipment right up until I got my hands on it. Where this one's obviously been sitting around for a long time in disrepair or being, you know, shoved off in a corner and not being loved and cared for. But let's open up that one and see what we've got. All right, we've pulled the thing open, or opened it up. There were only 4 screws holding it together instead of the 3, 6, 9, 12 that are supposed to be in there. There's an awful lot of dirt on the tubes. It's filthy inside. But what is interesting to note, copper plated, and this was something they did back in the day. Incidentally, the older manual I had, which is very similar to this unit, haven't opened it up yet. We'll take a peek inside here shortly. The older manual is from 1950, I believe. Let me take a quick peek inside so that I'm not lying to you. And it says here, oh, that says 3 of 52, 8 of 50, 8 of 1950. That says 3 of 52. So, and that says 8 of 50. Some of the manual is from 1950. Some of it's from 1952. The one I had from Tucker says 54, 1954. So by 54, they had gone to the miniature tubes. They had started changing over to the different tubes. So it'll be interesting to see how close either one of those schematics actually is to the unit. We'll be close enough for diagnostic and for alignment to get these things up and running. Absolutely filthy, but inside of here we have an RF choke assembly, I'm guessing. We have the power cord coming out, going into this box, and then the power cord exits in the back. So I suspect the RF chokes that are shown on the schematic are probably in here. That both schematics for both versions show RF chokes on the power supply. I'm betting they're there. We have an, is this an OD3 or an OC3? We have a voltage regulator tube here to stabilize the oscillators. This is an OC3, or 0C3, more correctly. 6x4 rectifier, which appears, these tubes appear on both of the schematics. Power transformer and filter cap. And of course, lots and lots of waxy capacitors that will have to go away before we power this thing up. Let's look inside the RF sheet. Looking inside here, I have a lot of hope for this little unit. I have to say I also have egg on my face. This is full of 7-pin miniature tubes, not octals. I don't know what the hell I was thinking when I made that comment, but anyway, it's full of 7-pin miniature tubes other than the 2 octals for the rectifier and the voltage regulator. There are no paper caps inside. I have not looked inside of this enclosure yet to see what's in there, but everything else that's in here are these glass tubular capacitors, which can be left alone. There's one mica capacitor here, or at least I hope it's a mica capacitor. I'll have to check the color banding and make sure. At any rate, we'll give it a test for leakage. Nothing is smoked. There's plenty of filth inside of the enclosure, the RF enclosure here, but that'll clean up. That's just dust and dirt. That'll come right out. So the unit should clean up fairly nicely. This little piece here is rather interesting, and let me zoom in a little bit on that. And there we go. That is how they do the sweep. And basically what this is a permanent magnet and a voice coil, just like a speaker. Just like you'd have for a speaker driver. Instead of a cone on the speaker, however, it's got this little aluminum disc right here. And on this piece of phenolic, just below it, is a coil, a single turn. It appears, at least that's what it looks like looking in from the edge. This is a variable reactance unit. And by applying AC current through this, through a series of resistors, which you see here by, depending on what your sweep is, and there's a variable wire wound one here, the speaker, quote unquote, will either vibrate a little bit or a lot at the 60 cycle line frequency, and vary the frequency of the fixed oscillator, or your fixed oscillator, the tunable oscillator here. You would set the center frequency, and because this little disc will be moving up and down, the frequency will swing back and forth about the center frequency set by this variable capacitor. A mechanical solution to the problem of how do you sweep the frequency. And in the manual it mentions if this gets noisy, there is an adjustment here to snug up on this thing. I haven't gone through it step by step. I just briefly read through the manual quickly. But this oscillates up and down at 60 hertz just like a speaker cone would, and sweeps your frequency about whatever was set by the variable capacitor there. So I'm going to clean this up, put some paint. We'll squirt some paint on the cabinet. We'll change out the 3 waxy capacitors that I can see, and the filter capacitor that's in here. I'm sure by this point, since 1950, I'm sure that's well past its sell-by date. And then we'll do a quick alignment on it. And let's zoom out here. Oops, wrong way. Zoom out, buddy. We'll do an alignment on this thing. And after that's done, or I should say as soon as that's done, then we can move on to the long-promised Alenco AM/FM transistor kit that everybody keeps asking me when I'm going to get around to building this. I actually did build the audio amplifier blocks for this a long time ago, and then became somewhat saddened at the quality of the circuit board that's supplied. It looks very nice, but solderability is hard. But at any rate, now we have a sweep generator to take us through the FM alignment with some antique test gear, just to show you how that's done with older gear. We could have done it with the modern gear. That would not have been nearly as enjoyable as using our $10 test bench stuff to do the FM alignment of that receiver. And we'll cover FM discriminators, FM product or ratio detectors, and how they operate. We'll give you a rundown on that and show you how to align them using our vintage test equipment here. So next time you see this, it'll be cleaned up. Okay, and here we are. Let me get these things off my belt. We don't need to be listening to those rattle. We've redone the front panel here and put all the knobs on it. I still have to pick up a set of matching screws for the front. I'll swing by the hardware store and see what they've got for a selection, find something suitable to put a full set of matching screws. But the front panel's all cleaned up. The lucite indicator is all cleaned up and nice and clear now. There's a little bit of pitting on the dial, but it's not very much, and I hope you can see how much better that front panel looks. Now that's done with my absolutely secret formula that I can't tell you about, or I'll have to kill you. But we all us restorers have our secrets, and my secret formula for cleaning the front panels will have to remain a secret. At any rate, we've squirted a little bit of paint on it over the wrinkle finish, and the rust is gone. We pulled the ID tag off the back, sprayed it, put the tag back on, trimmed off the broken section of the cord. The original cord's actually in pretty good shape, and I love that vintage looking plug. There was just one little bad section up in here. I clipped it out of the cord and put it back in. We put some feet on the back. Those were missing, and replaced the ones that were rotted off the bottom. And we did a full calibration on this thing. Now originally this came, oh, by the way, I did find out what this thing is. This is an Amphenol 80MC1M. And these are pretty dear. I actually had one in my junk box, and I didn't even realize I had it. I went down and pawed through my pile of connectors, and sure enough, I came up with one. And I priced some additional ones for the other unit. You saw the newer unit in the beginning of the video. I'd like to have one for each of them. And I'll tell you what, they're asking almost as much for these individually as what I paid for that unit. That was 10 bucks. They want $9 for these things. But I ordered one so I'd have one for the other unit, because the other unit costs a lot more money. So I figured it's justified to buy a connector. That way I can build the matching box for both of them. I'll have one each. The newer unit goes up to 900 megahertz. This one goes up to 480. However, I did notice the dial on the newer one doesn't have quite the band spread this does, so this is probably going to be a little bit easier to use. Now, back to the crystals. Originally, this came with a set of crystals. There would have been a 10.7 megahertz for FM alignment. There would have been one for TV-IF alignment. I believe it also came with a 1 or 2 megahertz crystal so you could accurately calibrate the scale. This is advertised as having a 1% accuracy, and believe it or not, after I repaired this thing, we replaced the filter capacitor, we replaced these waxy paper caps. There's another one, there's a couple more, so there were 5 paper caps in there. These were across the AC line. I replaced them with the correct Y-rated capacitors. And we had one bad vacuum tube. That tube was so dead it had 0 emissions, and I mean 0. When I turned the filament voltage up to about 30 volts, the needle on the tube tester started to wiggle a little bit. Very unusual. And what's really odd about this is it doesn't appear to have been gettered. It has the getter wire in there, but it doesn't look like it was ever flashed. Now, if these leak air, the getter turns white. The silver flashing turns white. And this one does not appear to have leaked air, or let's put it this way, it may have leaked air, but because the getter was never flashed, that's probably why it failed. It probably poisoned itself. This filter cap was as dead can be. It wasn't shorted. It's supposed to be a 16 and 16. The schematic says 20 and 20, but this one was a 16 and 16. Absolutely does not read capacitance. It was just about as dead as you can get. And every single one of these capacitors was leaking voltage heavily at the 25 volt level. And a couple of these are actually 400 volt caps. That one's a 200. Yeah, these are 400 volt capacitors, and they were seriously leaking at 25 volts, so they had to go. We calibrated this. Now, calibrating these is a little bit tricky, and the reason it's a little bit tricky is this is all based on harmonics. This particular unit uses a 75 megahertz fixed oscillator, a 35.5 megahertz fixed oscillator, and the VFO, and I forget the range of the VFO. The VFO goes from, well, let's see, band C. It goes from about 75 megahertz to 120 megahertz fundamental frequency. And it mixes with the other 2 oscillators to create all the other bands. This thing is so rich in harmonics that you can't use a frequency counter to set it up. Now, I had to use my spectrum analyzer. Now, another way to do it, of course, is with the crystals. If you have the crystals that came with it, they can be used to calibrate it by looking for beats on an oscilloscope. However, I don't have the original crystals. I'll be looking for them. I just put these in here to test the crystal oscillator, and it works just great. I use my spectrum analyzer. Now, most of you out there aren't going to have a spectrum analyzer to set one of these up with, but this is advertised as being 1%, and after over 60 years, this was built sometime in 1950. This is an early unit. It doesn't have the oscilloscope retrace blanking switch built into it, and it's not inside at all either. It's not wired in. This unit simply didn't have it. It would be easy to add, but I don't want to tear up the front panel and add a switch. It just goes against my grain. At any rate, I did some frequency checks on this thing, and its lowest band down here is 5 megahertz, and that's done by mixing oscillators together. It was within its 1%. It was about 47 kilohertz off, and on 5 megahertz, 1% would be 50 kilohertz. So it was within spec after 67 years. That's incredible, especially after I changed the tube and put the thing back together, cleaned it up. Now I have made it better than that, and I have also done what I did on the other oscillator over here, the one in the background. The way these were calibrated at the factory to use the logging scale. So I've done the same thing with this one for some of the important frequencies. Example, and excuse my chicken scratching here. The 10.7 megahertz on the logging scale is 48.65, and that puts me within 1 or 2 kilohertz of being right on the money. Now that may sound ridiculous to people used to digital equipment, but believe me, 1 kilohertz for doing an IF alignment is more than close enough, especially when you have a plus and minus 75 kilohertz bandwidth. This is a couple of orders of magnitude more accurate than the dial on your receiver. Let's face it, you have like 88, 90, 101, 110 on your FM scale. This is far more accurate than you're ever going to get on your receiver. This is how it was done back in the day. They would put a 10.7 megahertz crystal in here, select it with this switch, and then when you had your oscilloscope hooked up to your IF strip, you'd be able to see that pip at the 10.7 and dial in your IF an equal amount of either side of it, and using it in conjunction with that unit, you can inject the signal over here. You can find your two side points, your plus and minus 75 kilohertz, in your IF response. So very useful piece of equipment. Now that we have this up and running, we'll be able to get back to the kit that's over there and do our IF alignment on our 10.7 megahertz FM section, as well as the 455 kilohertz for the AM section using the standard signal generator. This way we can teach you a little bit about FM detection versus AM detection, demodulation, whatever you want to call it. And we'll go through the difference between a discriminator and a ratio detector. Discriminators were the original ones that were used way back in the day when Edwin Armstrong developed FM. Quite a story there. He developed the super regenerative, and then he developed the super heterodyne, which we all still use today. And then he began experimenting with FM because, being a very bright guy, he understood that frequency modulation would be much, much less susceptible to noise. So he developed an FM system and then went to Mr. Sarnoff of RCA fame, ABC, was it ABC or NBC? I forget which one Sarnoff was. Anyway, he was a very rich man who had known Armstrong in the early days, so Armstrong figured he'd go in and get Sarnoff's support, a little extra seed money to get this up and going. Well, Sarnoff stole his ideas, and Armstrong died basically penniless. And Sarnoff, of course, went on to be a multi-millionaire. So be careful who you share your secrets with. At any rate, I'll get off that bandwagon. It's quite a story. You can look up the story of Edwin Armstrong and Major Edwin Armstrong, and Mr. Sarnoff. At any rate, we've got this up and running. It's calibrated. Like I say, I used my spectrum analyzer to calibrate it to net everything in. So I've got this thing now dialed right in. It is working beautifully. Hopefully now, with new capacitors in there and a little bit of tender loving care, this will be good for another 60 years. We put some dye on the handle. Remember, the handle had big white patches on it. It looks darn good at this point, and now I have the matching pair. I have the sweep generator and I have its companion signal generator over here. And hopefully at the flea market coming up, I will be able to find Boy, these things are heavy. I will be able to find the companion signal generator for this version. I cannot get over the condition of this. I mean, it is just scratch free. Other than the chips in the paint, which are easily fixed, there's no scratches, there's no dents, there's no dings. I have not even opened this one up yet. Now this one uses a different set of oscillators, I believe. Again, I have not even opened it up. This one, go looking at the manual here, produced by, this one I think has 166.5 and a 191.5 megahertz pair of oscillators built in, fixed oscillators that beat against the VFO. Same scheme that the older one uses, but just higher in frequency. That probably is how they got up to the 900 megahertz frequency with this one, with a much stronger harmonic. I'm sure this produces harmonics up to 900 megahertz, but they're probably not strong enough to be real useful. Again, the scale on this one is a little more cramped, probably a little bit harder to dial in, but again, it still has the logging scale, and the logging scale will allow you to get very accurate. Ooh, there's some backlash. Hopefully that's just the knob. Let's see. Hang on just a second. Okay, it was just a loose knob. Now there's zero backlash. These use a ball bearing vernier drive. I did just notice the screws behind the knob here that hold the dial plate on have some oxidation in the CAD plating. The ones around here have slight oxidation on the CAD plating. They'd clean up fine, actually. I could polish those up and reuse the original screws. At some point, I'll get inside of this one and restore it as well, but for the time being, I will use the matching pair that we have here on our $10 test bench, because this one cost me $10. That's it for now, and hopefully the next time you see me, we'll be digging into that AM/FM receiver. I'm the Radio Mechanic. Hope somebody found this slightly interesting. Talk to you later.